Except if you have something that you want to share after.
Yeah, well, can I share something real quick beforehand? Because I want to caveat the canister size. If you recall, my video I think says 8 gigs, and so does the diagram, where it's gone beyond that, and it's like 48. And then I think 8 hours ago they said they're going to work on 64 because they're comfortable with it based on the Bitcoin canister they're managing. But if I could just get 2 seconds to say that, and then you can hit play, that would be cool.
Yeah, sure. Okay, let's go. So. One moment.
Actually, are we live now? Someone just chatted.
Yeah,
Hello,
we are live.
everybody.
I'm just sending the latest
Yeah,
reminder.
no, I can. You don't have to listen to me. I can tell everybody what I just said. Hi, my name's Matthew. We're about to listen to a video that was actually created for the last boot camp, but it's still very much pertinent today. And my colleague Dan Ryan is here. At this point, you probably all know Seb. And just one thing to note is within the video and on the slides that it presents, it talks about the size of the available memory, and that it's, I think it says 8 gigs in the presentation. That has, since been changed. It's up to 48, I think. And Manu just announced in the forum that they're going to take it to 64. The theoretical limit is 300 gigs, and we'll get into that. And then there's a whole nother thing, which I don't know how much I touch specifically, but there's always going to be at the moment only 4 gigs of runtime memory. And so it's 4 plus another 44. Anyways, pay attention to that, just that's not true anymore as much as it was true. And please enjoy, and we'll talk to you after.
So I kept talking about this lecture, saying like you will see about the different memories and all those things, how to upgrade your canister. So this is finally this lecture. It's about the different types of memory that we've seen, and the stable keyword we've talked about. So I'm going to go to the beginning. Can you confirm that you hear the sound? Is the sound good? Yeah, okay, thanks.
Yes, okay, sorry, confirmed. I was on mute.
Okay, good lecture, everyone.
Hello, and welcome to day 4 of the January 2023 Motoko Bootcamp. My name is Matthew Beekman. I've been building and transforming companies for 25 years, and right now I'm working with a colleague on an internet computer platform called IC Pipeline. His name is Dan Ryan, and he actually gave a presentation on day 1 about the Dfinity's SDK called DFX and how to use it to deploy canisters on the internet computer. I'm going to discuss with you today the basics of memory and data management on live canisters, otherwise known as smart contracts, specifically on the internet computer, using Motoko and DFX, as well as what happens during a deployment and how to leverage some of the available resources. Before we get started, I want to set a baseline so that you understand where I'm coming from. We came across the internet computer a little over a year ago, about the same time that the mainnet launched, and have been fascinated by Web3 and the advent of real-world use cases of blockchain technology, and the internet computer is just plain fascinating. So what we're going to see today is concepts in the way that we understand them, and in particular to try to show you how the internet computer does things. And even if you don't understand everything, maybe you can understand enough to protect your data and build your first application. In almost every computer system, there tends to be ephemeral or temporary storage options and stable or more permanent options. That stability could come from any number of technological solutions, but as a developer and an architect, the most important thing for you to understand is how to use these solutions to protect your data. So, for the context of our conversation going forward, we'll have two types of memory. We'll have heap memory, as in a pile of memory, which is memory allocated to the program while the program is running. So when the canister is active, you'll have your data, the data that the program is working on, will be stored in heap memory, or non-stable memory. Sometimes it's just called memory. There's then the concept of stable memory. It's a little more complicated to manage, but definitely worth it to understand and how to manage, if not leverage, to keep the data that is part of your application always available, even during and after an upgrade, which is the subject of this conversation. Next, we should talk about canisters. Canisters are, in essence, where your software or your program runs. And this slide has a couple different references to things like a virtual machine or blockchain hosted Docker. These are just ideas that might help you understand what a canister represents. But a canister runs a WASM, which is WebAssembly code that has been compiled in such a way that you can then inject it into this virtual machine called a canister. And while that program is running, or smart contract is running, it's interacting with memory pages. And Motoko provides a high-level interface for you to easily or more easily interact with those memory pages. And we'll get a little bit more into that as we go along. But again, the idea that I have a canister, the canister is then running my program then accesses and manages memory. I know these sound like simple concepts, but it's important for us all to be on the same page as we get deeper. Data Management 101. Protect your production data at all costs. That might sound a little obvious, just as the slide says, but if you've ever used a computer at all, you know that you need to save your data before you close the program. And what we're talking about is actually replacing the program or replacing the smart contract during an upgrade. And what we need to make sure that we know is what our options are in order to protect the data that is our production data, the data that's running inside of that smart contract as we replace the WASM or compiled smart contract. What we don't want to have happen is for you to upgrade your canister with the new version of your application and all your data disappears. You could have all your users and identities and transactions, and you upload a new version, and again, if you're not paying attention, all the data could just be gone, and there is no way to get it back at the moment in the current state of the internet computer, unless you have a backup someplace, but that's not the subject of this conversation, and you'd be in trouble. So, what do we want to do? Well, what we want to do is we want to move that data to someplace safe. Earlier we talked about heap memory versus stable memory. Heap memory is available only while the program is running, and you need to turn the smart contract off in order to upgrade it. So heap memory, anything in heap memory will disappear. What we need to do is we need to get anything that we want to save into stable memory. Motoko provides a interface through the use of stable variables. We will talk a little bit more about it, but stable variables can only be created from stable types, and we'll discuss a little bit about what that is, but there's also other hooks that you should be made aware of in Motoko that can help you manage this process. There are pre-upgrade, which takes place in the current version. So version 1 in this diagram will have a pre-upgrade hook available to it, or a function that can be executed. And then the orange block designates when the program is off, or the smart contract is off and being upgraded. And then when the new version, version 2, in essence, becomes active, it will first execute the beginning of the actor, which is the init section, and then it will execute a post-upgrade function. And we'll go a little bit more into that, but stable variables is a solution to get your data into stable memory, and utilization of some of these hooks and direct access to the stable memory pages is going to be another one. But this again is a high level, and hopefully this diagram will help you make sense of things a little bit more as we move forward. So what actually happens during an upgrade? At this point, you probably understand that I believe it's very important for architects and developers to understand what is happening and in what order, even if you don't understand all of the things about how it's actually doing these things, right? So this diagram should help you specifically with that, and how the DFX canister development kit that Dfinity has built and runs on your workstation actually interacts with the internet computer, and specifically your canister during an upgrade. And as you kind of get your head wrapped around the order in which these things happen, it'll make it easier for you to manage your data during this transition, because Dfinity, which they have committed to doing their absolute best through the CDK, the Canister Development Kit, to verify upgrade compatibility. It's on this slide. It's very important. The things that it does in steps 1 and 2, and that there's a whole wealth of reading that you can do on how it makes those comparisons and understands whether or not this is a viable upgrade, and or whether or not this upgrade will potentially destroy your data so that you can manage it. So now we have a base understanding of what happens during an upgrade, and that an upgrade is something that as developers and architects we need to pay attention to as a moment of risk to our production data. We're going to touch a little bit more on the code and how to write code and what actually happens inside of your smart contract, and what happens to your data, what happens to the variables. So on the slide right now, we have the beginning of a very simple example that I put together, and after I talk a little bit about this, we're going to switch over to the command line and VS Code, and we're going to actually run a deployment and watch as we make some changes what happens to our data. And as you can see in this slide, which I'll go reference in a moment, directly in VS Code, but I've declared a variable of type text called first name. I've called a additional variable stable, right? By having the stable word before var, it will actually tell Motoko that I want this to be stable. And again, what it will do is during an upgrade, it will store that data inside of stable memory. And both of those are set to nothing at the very beginning when the actor initiates. We've got two functions. One is extension of the greet function that was in the example that you've already done probably more than once, and it takes an input and kicks it back with a text string. I've added my first name and my last name to that text string, so if I put in Fred into the greeting, it should say, hello Fred, my name is blank blank, right? Now, what we're then going to do is we're going to execute update vars. Update vars is going to set those two variables inside my active canister to Sherlock Holmes. And I'll then run the greet again, and it'll say, hello Fred, my name is Sherlock Holmes. Then we're going to do an upgrade. After the upgrade, what you're going to see happen is his last name will survive because we've declared it as a stable variable. The first name will not. And so the next time we execute greet, it will say, hello Fred, my name is blank Holmes. Okay? And like I said, next thing we're going to do is jump over to command line and show you some things there. Okay, so as we were just saying, we're going to go ahead and move over to the terminal and VS Code and take a look at some examples. I've created a public repository on GitHub called Bootcamp Memory, and that includes the code base that we're about to play with and take a look at. So with that in mind, we'll jump over to a terminal here. I've got a split terminal, basically two different prompts in the same folder. I'm going to start the DFX server or replica, and I'm going to run clean. I'm not going to put it in the background because I want this to just kind of stay alive here and spit out messages, because we're going to use the debug feature as part of this demonstration and hopefully provide a little better understanding of what's happening and confirm some of the diagrams that I've shared already. So, I'm going to start. Looks like a happy start. You should bear in mind this message is a warning. I think a lot of folks were posting in the forum or in the Discord that it was a little confusing. This is new as of 12, version 0.12. And they're starting to consolidate some of the local replica things, and they've removed the network definition from dfx.json. And this particular lecture is not on how all that works, but bear in mind, this is a warning. This is a happy replica at the moment. We're going to go ahead and take a look at the code. This code is what we just shared in the slide. Again, extension of the hello application with a greet function or greet interface. And we've just added a first name and last name variable. So it'll say hello, whatever name you pass. Nice to meet you. My name is first name, last name. At first it will be 2 blanks, and then we'll update it to be Sherlock Holmes and continue with the example. So go ahead and do a deployment. Because this is a fresh replica, it will create the wallet first and then create canister and deploy it. I started this with a hello example. There is in the source code a front-end canister, but we're just not using it for this demonstration. So this is successfully deployed, and we'll go ahead and run our greet function, canister call greet, Bootcamp memory backend greet function and hello, nice to meet you, my name is blank space blank. So we're then going to run the update vars function, which will set those 2 variables to Sherlock Holmes, and then we will run the greet function again, and now my name is Sherlock Holmes. Now, again, the first name is a regular variable, and the last name is a stable variable. So we will change the code as if we were adding a feature or doing something new. So in this case, I'm going to reference, so I have a main basic and a main expanded. These are not being used when the canister is being built, only main mo is, but I've left them both here so that you can go and reference them. Expanded is what I'm going to eventually put in, where it has a bunch of neat stuff in it. So we're just going to quickly add the time module, or time from the base library, Motoko base library, and we're going to grab the time, and we're gonna, I'll do this down here, grab the time, add it to my greet function, right, and we will then print the time in my message. The time is okay, so it'll take this time value and print it. We got to add int. Sorry about that. Oops. Okay, save that. And we haven't changed anything about our first name or our last name. We've changed something completely not having to do with those 2 variables. And you would think everything should be the way it is, and I'm just kind of upgrading other parts of the program. The problem is that it is one program. A canister is one actor. It's a one-to-one relationship. You have to be able to upgrade that canister, and that particular program will have to be stopped to upgrade the source code. That's what we're talking about and have been talking about the whole time. So now, just to demonstrate it, we're going to do a deploy. And as expected, the first name has disappeared because that was not a stable variable. The stable variable of the guy's last name has maintained itself through the upgrade, and we know it's been upgraded because I'm now printing out in nanoseconds the timestamp at the time that we executed this function. Now, this is all very interesting. So what we're going to do here is we're going to actually do a new DFX start, and we're going to deploy this new larger program or smart contract and take a look at it together. It's utilizing a debug, as I mentioned, and it's got a couple other interesting things in it, but in essence, it is the same program that we were looking at, just expanded. So, started the new server. We're going to do a DFX deploy. This is, again, a empty canister that we were going to create and then put the first version of our smart contract into it. Because we have the DFX server running in the other window, we can see the debug output. So debug printed begin init time with a timestamp. Since this is the first time that this has actually ever had a smart contract in it, it did not trigger the post upgrade hook. Obviously, the canister also did not exist, and so there was no pre-upgrade hook to execute because it was empty. Now, I'm going to make a small change just to be able to initiate the upgrade, and we'll just add number 2 here. So begin init time 2, we'll save that. We'll go back, we'll do another deployment. And what you'll see here is 3 different timestamps. It does the pre-upgrade, right, which is the one here, pre-upgrade time. And then it replaces the canister, right, which would now have the new begin init time 2, right, which it printed here, begin init time 2. And then because it was actually doing an upgrade and not a brand new install, it ran the post upgrade hook, right, which you can see the output here of post upgrade time, right? So now this should hopefully help. You should also note that the timestamps are all identical because the canister state does not change during that entire operation of upgrade. And DFX and Dfinity in particular, has done a fantastic job in orchestrating these upgrades, but it's important for you to know, again, what happens and in what order and how to leverage it. So now I've got a good sense of, what order things are being executed in, and I've got my new program. But what I wanted to point out is I've created a new variable that is a stable variable. Again, just a very simple text to keep this conversation light. But my first name stable is a stable version of my first name. It starts out empty. Everything else in this program is the same, and I'm going to set my name to when I execute update vars. I've added an input just again to kind of show possibilities and to demonstrate debug, where you can actually have it show you other things than just a timestamp, but it could include the message that's being passed to it or the caller, in this case the principal of the caller. I've got it printing out some other things we can walk through in detail when we connect. But I thought it was really just a good example of how to maybe get a sense of what's going on in your program. So let's go ahead and run through the same set of interface calls. We're going to call greet. Hello, my name is blank, space blank. We're going to run update vars. Oops. Again, it has an input value now. I want to change the last name to Bunny. All right, and I run the greet again, and it's now Sherlock Bunny. Now, the thing that's interesting here is Sherlock is still ephemeral, right? So if I actually were to change smart contract one more time. So we'll do at time 3, we do another deploy. Sherlock will disappear, but Bunny will stay, right? So what we want to do is think about, well, we understand stable variables now, at least we hope so, and so that the last name is stable, and so thereby Bunny as the last name survived the upgrade. But if I was to actually add to the pre-upgrade, right, I'm going to uncomment this, and I'm going to set a stable variable equal to the value of the current non-stable variable. It will store it in that stable variable. It will then do the upgrade, and then that stable variable will be available to me during init. And I'm going to check it. If it has a value, I'm going to set it equal to the unstable during the init process, and I will then have my first name. So I'm going to actually, we have to do this twice because I have to enable the pre-upgrade and get that into my program. So we'll do a deployment there first. Okay, so in this case, nothing's really changed other than I've added this code to my pre-upgrade. So now when I call greet, I'm still just Bunny, right? So now what I need to do is I need to set my first name, and we're going to go back to the code, and just to change this, we'll change this to bugs, right? And we're going to do another upgrade so that, whoops, so that actually gets there. And then I'm going to do the greet, still blank because I haven't set it. I'm now going to set it, right? That should now set it to bugs. So if I do a greet, I'm now bugs bunny, or bug bunny. I don't say a typo. And the thing is that if I then fix that typo, right, what should happen is it will save the value of my first name as bug on this next iteration, and then I have to, basically execute the update vars in order to get it to be bug. So like this will force an upgrade, right? Actually, forgot to save it. Sorry, folks. So force an upgrade. I'm then bug bunny, but if I then run my update vars, I will now be bugs bunny. Meanwhile, I've been spitting output to my debug the whole time, so I can go back and I can start to check the history of what happened. And if that history doesn't include what I need, I can go back to my program and add more debug messages, right? So if I wanted this to be more robust, whatever the case may be that I want to feed out to it, I can then do that, and those new messages will then be outputted while I'm executing my program. Look, I hope all of this has been helpful. I know that it's a lot. I know it's coming at you at 1,000 miles an hour, and other than getting your hands dirty and trying to understand this stuff by doing it, this is really your next step. And feel free to download this repository, play around with it. All this code that we just went through is available in it, and I look forward to seeing you out there inside the internet computer. And with that said, if this is the beginning of the live session, we can move to some questions and answers. Again, my name is Matthew Beekman. Thank you very much for everything. Hopefully this has been helpful. The opportunity is appreciated, and I wish you all great success. Thank you very much. Bye-bye.
Thank you, Matthew.
Yeah. Thank you for the opportunity. Thanks everyone for joining us. Yeah,
I'm
it's an
looking
adventure you're
into
on.
the Q&A. So we don't have any open question, but we have a few in the chat. I can see the last one. So in a canister, you have heap and stable. If I make a game and I need to upgrade it, yes, all the progress will be lost unless you store in stable memory.
Yes. There's a hair or two on that as well. You need space for serialization if you're going to start managing large amounts of data, right? So it needs enough room to do what's called serializing. So a stable variable, just this might help folks that are coming from other programming languages. A stable variable is one where Motoko, in essence, serializes, takes the variable itself and turns it into storable binary code that can be basically broken up into bytes and chunks that it puts into memory pages. And you need enough room to take that active variable, let's say it's a hash map or a tree map or something like that. Actually, tree maps I think might be stable now, but part of the great thing about this, again, adventure you're on, is the team and the community are marching forward, right? So a lot of variables that when I first was learning a lot of this stuff that were unstable have basically, there's stable versions have come out. So I encourage you to take a hard look at the base code and the release notes, and what was true yesterday might not necessarily be true today. But going back to serialization, regardless, if you have 4 gigs of RAM, which in essence you have, or heap memory, it is unstable memory, right? But that's where all the work gets done. And you need enough space in order to take your data that you want to save in that upgrade and serialize it. So you need twice the amount of space, if that makes sense, because you're still going to have the active variable, and then you'll now have this serialized variable, and that serialized variable is then what will be written to these memory spaces or memory pages and put onto the non-volatile RAM that I shared the link in, which in essence is a hard drive, even though there's no spinning disks or anything like that. But in straight up computer world, you have RAM, which is volatile, does not survive reboots, and then you have your long-term storage, your hard drive, if you're old school enough, and that hard drive would in essence survive losing power, right? You can take it out and put it in another machine. And I don't know if that directly answers your game question. There's some really cool projects out there. CanDB is a good one to look at, but ones that are spreading data and into those memory pages aggressively, where they've kind of handled a lot of the learning curve and turned it into a product that you can use. Demergent Labs has some cool stuff. There's a GraphQL data base, and there's I think that either they or somebody else did a SQLite database, which kind of manages a lot of this stuff and takes advantages of the full 48 gigs. So if you built your game on top of one of those, you've got a team of people that are aggressive in their own learning curve, and you can then build on top of that, so you can concentrate on the game. That would be a recommendation, but still understanding all of this stuff, for troubleshooting, for keeping up with their updates, stuff like that. Highly recommend that you try to understand this process, even if you don't necessarily know how to write the code to make it happen. But I think I said in the lecture, there's a diagram, and I'll shut up here in a minute, but there's a diagram that talks about the steps that take place during an upgrade. You're in essence turning the machine off, upgrading the program, and then turning the machine back on, if that kind of helps your brain.
Right. And just for clarity, Matt, excuse me, you were referring a moment ago to if when operating at or near the storage limitations of a given canister, there are use cases where one may need to factor for the transitional doubling up effect of serializing the data in transit, so to speak.
Exactly.
Yeah.
You know, where if you think about it, you have two different types of buckets. You have an unstable ephemeral bucket, and you have a stable bucket. You have to fill up the bucket before you put it into stable memory, right? So like you have to actually have twice the amount of space. So like if this is your unstable and your game's going along and it's doing all sorts of cool stuff and all the data's changing and users are using, and now you're like ready to do an upgrade, it freezes. You then have to build up a, you know, stable version of it and then move all that into memory and then upgrade. Everything disappears except for your stable memory. And then when you turn the thing back on, it takes that stable memory and then it rebuilds the dynamic one. And then it says, okay, now you can start doing the game again. And that process, the mental process, is extremely important, because regardless of whether you're building on top of somebody else's, you know, data platform, you need to understand how this works, because there will be components that even you as a developer, you know, you'll pull data out of that database to do work on it. You know, when you're doing work on it, it's ephemeral. And so anyways, yeah, what Dan said, and just expanding upon it. I think there should be one thing that also thrown out there for those that have been around for a while. You might have lived in a world where 32-bit operating systems were prevalent, and in particular, if you're pushing large data sets, as data sets got bigger and bigger and bigger. Let's take Linux as an example. Right, Linux, a 32-bit version of Linux, can only talk to 4 gigs of RAM. Right, as an anecdote, the way I learned that was by putting in 8 gigs of RAM into my desperately starved web servers, and actually did it across, you know, 4 and 5 machines that were actually my array of web services, and I could not figure out why my newly purchased RAM was not available. And it's a 64-bit versus 32-bit operating system thing at the moment. The WASM, that is the canister running on the internet computer, is running in a 32-bit environment, which puts the limitation of 4 gigs for heap. And there is a timeline that I don't know the specifics of, if it's been defined when, but there is a ongoing process to turn the internet computer canister into a 64-bit operating system, in essence, which would then expand the ability to have larger heap sizes. So just put that in the back of your head too, as a change to pay attention to.
Right on. Cheers. Yeah, no, as you were talking, I was thinking about the kind of analogs between this and thinking about it in call it Web 2 analog type stuff. Cool.
Yeah, I know in both our discussions, Dan and my discussions, we've been at this for a long time, and so the trying to make parallel understandings of how this stuff works is part of why I'm saying this stuff. again, how to use it without necessarily having to know all of the details, why, knowing where your limits are, and then building inside of that. That's really what this lecture is trying to talk to you about. So Ryan, from my understanding, you can't make a hash map stable. So basically, this is the pre-upgrade, post-upgrade example. I do believe there might be, hash or tree maps that are today stable. They might be part of the community, or they might be part of the base. Seb might know better. I just haven't stayed up with it because we haven't needed to change anything that we're doing on our project yet. So it's a reality of how much time you have to stay on top of everything. But let's say the hash map is not stable, and it was not stable. What you would do is you would take that hash map, and there's a function that allows you to convert a hash map into an array. An array is a stable type variable. So you would create a new variable that is the array and that it's empty. And then on pre-upgrade, you would take the hash map, convert it to an array, and set it equal to that stable variable. And then when it boots, when the contract upgrades, it would take that stable variable and rebuild the hash map, because after the upgrade, the hash map is empty. Sorry, you're about to say?
Yeah, I was saying, I think I'm trying to show the example, but I'm getting a bit confused with, like, it's been a long time I didn't do it myself. So like, it's like array to iter or from iter, or I don't remember exactly which is the good one, but I'm just trying to use the student entries. So the idea is to have an hash map here and store everything inside the hash map. But this hash map is in the heap, so of course it's going to be reset on the upgrade. And so the trick is to define a stable variable for the entries of the hash map here. It's empty on initialization, but on pre-upgrade, the idea is to put everything from the hash map inside the array, and then on post-upgrade to put it back. Or also we can just create the hash map from the student entries. I'll try to do it like this, I think. So I think this should work. I don't know what's happening here. Students entries. Maybe it's because of this.
There's no type output, so that, yeah.
There. Yeah.
You gotta add iter. So what he's doing here is that, again, just to reiterate the order in which this happens, while this thing is active, it's going along, and then you say, I want to upgrade. Before it does anything and turns itself off, it runs pre-upgrade. It turns the student entries array into a result that is actually what's in the current hash map at this moment. It upgrades the smart contract or the canister. It will then go through anything that might have changed in the initial declarations, and then it does post upgrade, in which case it is rebuilding the hash map as far as what Seb just did.
So yeah, let's go for Matthew. Well, I put the name here, so I'm just gonna go with an ID. Let's see. I think it's more clear if it's in another frame. So now we should see it here. And we can go back and upgrade. So let's say let's just add a variable. I think we need to add something just to be able to upgrade.
Yep.
And if we refresh, so we just upgraded. And if you remember all the lectures that we've done so far, all the examples, every time we upgraded, it was reset, but not this time. Yes, this time we still have the records. And this is and this is because of those system functions, so pre-upgrade and post-upgrade that are used before and after the upgrade. And so, yeah, we can also try without it in this case. Yep. So in this case, we lost everything. And what we mentioned, I think, during this lecture as well, is that it's pretty dangerous functions. So that's why it's also good to have access to the stable memory, because imagine that. Okay, I'm going to do it. I don't know if you can do that with the playground. Let's see. So if I do that, like right now, this is the code inside my canister. So it's always going to trap in the pre-upgrade, right? And so now if I try to upgrade again, let's do it. Let's just remove that. It should like fail basically, but I don't know, because with the playground it might, yeah. So I can't upgrade my canister anymore. And of course it's not too bad, it's just the playground. But if you have a real canister with real data, and of course you're not going to add this, you're not going to do that, but it can happen that something wrong is with your data structure, or you've forgotten to, like, there is a trap for some reason. And so, yeah, you can get stuck in some kind of situation like this. So it's a topic of the IC that is constantly evolving. I know that, like, people are working on stable data structures. Definitely is also working on making Motoko more, basically making Motoko abstract away all of this, which would be huge. And they will have the possibility to do it because Motoko is designed for DIC. Actually, I heard recently that they want to basically put the heap in the stable memory, and just as a developer, you will just have access to one memory that is always stable. And I think that'll be huge if they do that. Yeah.
Yeah, well, I think that's the result of, or not the result of, but one of the advantages of going to 64-bit operating system. I think you're going to be able to expand that out so that it does the accordion process, so like you can actually expand to store it and then shrink it back down, because just like in that, what Seb did here with the assert, if you were in the process of like working transformation from a half map to an array, and you ran out of memory, I think it blows up too, right? And so that basically you're stuck. A function that was working fine when you had 5 users, and now you're successful and you have 1,000 users, and your game is kicking butt. And the next thing you know, you lost everything because it got too big. And this is a big warning / pay attention, folks. It's one of those things that, like, success could break you. And you want to try to avoid that.
Yeah, to get there, you need to get a lot of users, or like at least some kind of huge application usually. We have a
Yeah,
good
and
question. We have a
good.
good question in the chat. It's if you forget to make the variable stable in the array in version 1, and then you add it in version 2, will the information be lost? So I believe that yes, because when you do the upgrades, like the first time, it's not gonna, if you add something, like it's gonna be based on, like the new module can only be installed after. So yes, it's gonna be lost. And yes, this is a good question. When you, like, one little thing I can add is that when you upgrade, the pre-upgrade that is gonna run is the one that is installed in the canister, but the post-upgrade is the one that the new one. So like, yeah, this is something to keep in mind.
It has to already be there in order to save you, basically.
To be there?
Well, like you have to have it as a pre-upgrade.
Yeah.
It has to be in the code. And that's part of like, play with this, right? Like create this example that Seb's got going on here, and throw in some debug messages so that you kind of understand the sequence of time, right? The video that I put together here, there's maybe not the best example with Sherlock and Bugs Bunny. It might have got a little confusing, but one of the things that it also had was an example of how to use debug and how you can start understanding the sequence, which, honestly said, is exactly how I learned what I'm trying to lay down for you today. You're putting thermometers and measuring sticks in your code that help you understand the progression, whether it's be, this memory conversation or even just your sequence of events for your game. Debug is a beast. And if you're new to development, the more logs and information you're getting about what's going on, because it can print out the values of variables at the time that debug message is. So like if you're supposed to do x+1 and it's coming out as x+5, right? It might be because your function's running 5 times, right? And if you actually had a debug in your function, you would see it's actually executing. It was 1, then it was 2, then it was 3, then it was 4, then it's 5. And anyways,
there are a few good questions I'd like to try to answer before we go with wrap up. So someone asked, like, you cannot make a hash map stable. So like you cannot make the hash map from the base library stable because it's a class, and a class cannot be stable. Any class, like the buffers cannot be stable, the hash map. But there are hash map, like in hash map, the data structure, that are stable from the community, like people have built on libraries, but it's not the hash map from like the base library. The hash map from the base library cannot be, and it's the same for buffer, and any class cannot be stable. So I hope it also answers the question of someone that asked, how can we find out which types are stable? So there is a good documentation page, I think. It's one of those things that you have to look in.
had it up. This reference array.
Yeah, you can read that. I think you have a few indication of what is stable. There are a lot of rules, but basically the only thing I keep in mind is like any class cannot be stable, and the rest usually can be stable. Like array can be stable, list, of course, natural numbers, int can be stable. And so how can we get the canister status? So we can do something like this. Is it the one I wanted? you can do, for example, if I want to call the verifier, so like the canister that is verifying all the projects, I could use this command status. So you need to get status and then either the name of the canister or the canister ID. I hope you can see. So yeah, you can see like the status. So it's either running, stopping, or stop. The controllers, and you have a few more information like memory size, balance cycle, the module hash, freezing threshold, memory allocation, compute allocation. Yep. So for the classes that are not hash map, you do just put the class variable in array.
I don't understand the question.
Yeah, me neither. Is it best practice to clear the stable variable? Yes. Usually you put and then you clear you put back into the non-stable and then you clean up. Okay, I think we're good.
Which releases the heap, just FYI. So like if you don't do that,
Yep.
you're kind of taking that available space up double.
Right.
Is there a way in Motoko to get the controllers when calling a remote canister? Yes, there is a way, because I'm checking that you are the controller of the canister that you submit. So I can say there is a way. And I also linked the, it's kind of a tricky way to do it. So I linked the actual code sample. I guess it's for day 5, right? So I think it's it's not the good place. Yeah, okay. Let's see that in the mentorship session. I think we're good for this lecture. Okay, one last question. Yes. In the pre-upgrade method, you have access to everything that is inside your canister. Like it's gonna run before the upgrade, so you have time, and there is just a limit on the number of like instructions that you can run. So it doesn't have like you need to stay inside a certain range, but yes, you have access to all variables. Okay. Well, thank you, Matthew. Thank you, Dan. And
Yeah, thank you, Sid.
Everybody.
have a good
Keep at it, everybody.
yeah. And so next session is a mentorship session in 2 hours. And we also have a quick gaming session in 1 hour. For anyone that wants to relax, I'll be there. All right. See you.
Bye.